12.8, translations of trigonometric graphs. So now we're going to talk about all the basic graphs we did last time, and then we're going to move them up, down, left, right, like we always do with graphs. So the first time movement we're going to talk about, the first type of shift, is called a horizontal translation. Better known when we talk about periodic functions as a phase shift. So we move a graph left, right, and call that a phase shift to be proper. So a horizontal shift is when something's on the inside, right? So we do inside opposite. So we move it left and right. Right, so you see something inside that moves it left and right, the value it has there. So let's talk about, let's do an example, let's talk about it. Let's make this pi over 2. Your book has a weird thing about degrees, no one graphs in degrees. So let me rewrite this. This is sine of theta minus pi over 2. So we treat everything the same. Let's find our amp. Amp is in reference to 1. Let's try a period. Period is in front of the theta here, which doesn't have one, so 2 pi over b. There's no b is what I meant to say, right? There's no b there, so 2 pi over 1. So 2 pi. And then we have a phase shift. That's how much we move left and right. Inside opposite, so we move right pi over 2. So phase shift is not the bad part. It's where does your graph end? That's the bad part. It's 1, 1. So here's a little trick. So phase shift is pi over 2. Let's do pi over 2 right here. Then let's count by pi over 2. So another pi over 2 would be 2 pi over 2. Also known as pi. Another pi over 2 would be 3 pi over 2. Another pi over 2 would be 4 pi over 2. Go to 5 pi over 2. Then like a 6 pi over 2. Basically, whatever you're moving it, keep that as your the basis for what you're doing. Okay, so let's talk about a phase shift and how that works. Again, the hardest thing about a phase shift is not actually doing the phase shift part. Plus pi over 2, that just means we're going to start right here. The hard thing is, where does my graph end? Well, it's not as bad as it looks. So we're going to start here at pi over 2. And then, do you remember what we call it how long it takes the graph to end? We call that a period. So all you have to do is get your phase shift and add the period. That lets you know when your graph's going to end. So in this case, I got to add fractions. That's always kind of a pain, but whatever. Over 1, this is 2 and 2. So I get 4 pi on top. 4 pi plus 1 pi is 5 pi over 2. So I got to stop right here. That's me one rotation, one period. It's 5 pi over 2. So I start at pi over 2, go all the way to 5 pi over 2. Other than that, we're going to graph it like normal. It's a sine graph, so that means we're going to start at the middle. We're again at 5 pi over 2. And we got to cross halfway. You can most of the time you can just eyeball it, but if you're not sure, how do you find halfway? You add up and divide by 2. You have pi plus 5 pi divided by 2 is 3 pi. So 3 pi over 2 is what we're doing it at. That's halfway. In between these two is my highest. In between these two is my lowest. And he's connected. And again, this graph goes on forever and ever, and ever and ever in the back. But that's how you do a phase shift, right? It's all about inside opposites, so move it that way. And then add the period. Add the period to your starting point, and then that's how you get your end point. Let's do another one. We pretty much already did that, so let's skip that one. Tan, like I said, we're not going to actually do tan. It's the same idea that you move your thing over right for, but you do with that in our math analysis. Let's do cosine. Let's do 2 cosine theta plus pi over 4. Oh, and let's make this a 2 on the outside also. So let's just let me rewrite that because, whatever. 2 cosine 2 theta plus pi over 4. So in this case, let's draw this one, right? I'm going to find my amp. So which is 2 and we're on the outside. I need to find my period. There's my b, so 2 pi over b. So 2 pi over 2. So just pi. My phase shift, inside opposite. So this is going to be negative pi over 4. So I'm going to start at negative pi over 4. And like always, I think the best way to do this is just draw a line. Start at your phase shift, so negative pi over 4. Start counting by it, so 0. This will be pi over 4. 2 pi over 4. 3 pi over 4. 4 pi over 4. I can keep on going if I want. Amp is 2, 1, 2, 1, 2. This time we're graphing cosine. So we're going to start at negative pi over 4, so we're going to start right here. So negative pi over 4. As always, we got to add the period to end it, plus the period, which in this case is just pi. So we need a common denominator. Negative pi plus 4 pi is 3 pi over 4. So we're actually going to end right about here. Now we're going to graph cosine on this graph. So our cosine starts at the amp, so we're going to start right here at 2. We end at 2. Halfway between, now we have negative pi and 3. So again, if you want to figure out where to go, just add them up. Negative 1 plus 3 is 2. Right, you find the average, so you always add them up, divide by 2. So I just get pi. In this case, we're talking about over 4, so pi over 4. I'm not sure. So that's my lowest. In between these two is where you cross. In between these two is where you cross. And that is my cosine graph. Goes on forever. Right, so same idea. Oh, there's a phase shift, so you move it left, pi over 4, where that phase shift is. You want to figure out where you end, you just add the period. That tells you how long it takes for it to repeat itself. And that's the idea. The next one, let's do one of these, your book's favorite, which is doing it in degrees. So again, no one really does this in degrees. When you get a calculus or whatever class you're going to do next, you're going to do it in radians. But it is a thing you could do. So let's talk about this. The amp is still 1. Period is now, since it would be 2 pi over b, but that's in radians. So if we want to do degrees, remember 2 pi is 360 in degrees. So it'll be 360 over b. Your b is still 1, so it'll just be 360 b bar period. So again, it's just like radians, but in radians, 2 pi in radians, 360 degrees. My phase shift, well, that doesn't change. Inside opposite, we're going to go plus 180. So let me draw it. Normally I go by pi's, but in this case, since we have 180, let's go 180 over here. Let's go another 180, so 360. Another 180 would be 540, I believe. Another 180 is 720. I think that's about it. So again, this is because it's in degrees. My amp is 1, so let's go up 1, maybe 2, 1, 2. And then other than that, we're gonna pretty much, it's probably maybe a little easier than the other one. Let's start at phase shift is 180, so we're gonna start at 180. Just like always, since I'm starting with 80, if you want to figure out where you end, you have to add the period, which in this case is 360. 180 plus 360 is 540. So I'm gonna end there. Other than that, it's a normal sine graph. Graph a normal sine graph. Sine starts in the middle, ends at the middle. Halfway is the in between spot. In between these two is my highest point. In between these two is my lowest point. Something like that. And don't forget, it goes on forever. Like if I was going to do this again, but let's add another 360 to figure out where you end. I can do the same thing backwards, add another 360 to figure out where you end. So that's how you do a phase shift. Let's move on to the vertical translations. I think this is actually easier. So vertical shift is something that affects the outside. So you see right here, it says it's on the outside of the function, on the outside of the function. And as always, vertical shift moves up and down. You follow. Outside, Y, follow. So let's talk about how to do this one. Now, a good thing here is that they call something a midline. That's, oof, I meant to highlight that. They consider that the line where you start off at. So if it's like this, they call this the midline, right? If we're doing a sine graph, they call that the midline. Some call it the principal axis. It all depends on what book you're reading. This book is called the midline. I just call it the middle personally. So let's look at this. We'll talk about how to do this one. So we're going to do cosine here. Let's do what we always do is find the amp. 1/2, oh, that's going to suck. Period. 2 pi over b. I have a b here, so 2 pi over 1. So just 2 pi. And we have no phase shift this time, but we do have a vertical shift because notice it's on the outside, right? It's on inside parentheses here. It's on the outside. It's going to go down 2. You always fall on the outside. So fairly similar to a phase shift, how you move left and right. In this case, what this vertical shift is, it's your new middle. Or as your book calls it, new midline. It's not the middle. So like when we're graphing a cosine graph, that's the middle. That's our new thing here. So -2, go down there. This is your new middle. at -2. Now my period's 2 pi, so as always we're gonna start at 0. We'll end at 2. That's supposed to be 0. We'll end at 2 pi. So let's go like pi over 2, pi, 3 pi over 2, 2 pi. We're again there, so we're starting here at 0. We're ending at 2 pi. Now what do we do next? Is our amplitude, right? My amplitude is 1/2. So from -2, I could go up 1/2. That's gonna so let's say this is -1. That's gonna kind of suck. It's like right here. That's the highest I could go. Oh, this graph. I could go down 1/2. So like let's say this is -3. I can't go that far. I'm gonna go half down to -2.5. This graph is ugly. So like that. So I can only go in between there, right? I start at 0 and I add 2 pi. I'm starting at -2 is my new middle, the bottom here, and I could go. My amps is how much you go up and down. I go 1/2 up and 1/2 down. Other than that, we're just graphing a normal cosine graph, normal everyday cosine graph. Remember, cosine doesn't start at the middle; it starts at the amp, so it starts right there. I'm gonna end at the amp right there. Halfway will be pi. That's my lowest for a cosine graph. In between these two is where I cross the midline. In between these two, where I cross, and that graph right there is my cosine graph. Move down to. And again, these go on forever. So that's the idea. This one that's a little easier to see because that 1/2 was brutal. Let's see. Let's try this one. Right. So in this one, my amp is 1. There's no thing there. My period is 2 pi over b. There's no b, so 2 pi over 1, or just 2 pi. My vertical shift, because you notice that's on the outside, is 4. So I'm going to start at +4. It's my new middle. Let's draw a line. 1, 2, 3, 4, 5. This is my new middle. My normal periods, I'm gonna go like pi over 2, pi, 3 pi over 2, 2 pi. Just do anytime there's no like funky period, just do the basics. And then this, after that we did it, let's figure out amplitude, right? Amp is 1. So from this middle here, I could go up 1. I could go down 1. Right, I'm starting at 0 because we don't have any phase shift, and I'm ending at my period 2 pi. Also known as 0 plus 2 pi is 2 pi. So that's like the little area of my graph. Then we just got to graph cosine. Cosine starts at the amp, ends at the amp, halfway is pi. That's my lowest, in between is where I cross in the middle. And you get a graph like that. Something to that effect. A couple more of these. Let's make some more interesting. Let's make it a negative sign. We haven't done one of these. Let's make it a negative sign. So my amp, now here's the thing. Amp, you might go, oh, it's -1. Actually, amp's always absolute value, so it's still 1. Because amp just says it's a distance. How high up and how high down do you go? It's a distance. So 1 no matter what. It's always positive. Period, 2 pi over 1, that's easy. So 2 pi. And my vertical shift is on the outside, so vertical shift is down 2. So if I graph this, 1, 2, 3, 1, 2, 3, the -2 is my new middle. Period still 2 pi, so I'm gonna go like pi over 2, pi, 3 pi over 2, and 2 pi. My amplitude is 1, so I'm gonna go up 1, right from my middle, and down 1 from my middle. I'm starting at 0 because there's no phase shift. I'm ending at 2 pi. So that's like the little box where I'm drawing my thing at. Now this one's a little different because this is a negative. If you remember what negative does, it's a vertical flip. So it's a flip upside down. So normally a sine graph looks like this, starts in the middle, halfway and you go up and down. Now we're gonna go upside down. So you start in the middle, and there, halfway is my midpoint. Now normally it's my highest point, but now it's gonna be my lowest point because it's flipped. And normally my lowest point, that's gonna be my highest point. So you go down then up. That's a bad graph at the end. There you go. That's a negative sine graph. Move down 2. We'll do the same thing for secant. I'm just gonna do some real quick. Let's say amp is 1, period's 2 pi over 1, so 2 pi. vertical shift to 5, -5. This one fast. 1, 2, 3, 4, 5, 6. This is my middle. My amp is 1, so I can go one above it. My amp, and then I could go one below it. Oh, that gets bad at the end. Another 2 pi, another basic one. I'm getting kind of boring with the basic ones. Right, I'm starting at 0, so don't phase shift, so you start down here. Ending at 2 pi. Now, the thing with this one is it's secant. Remember the way you graph secant, you graph its reciprocal, you graph cosine. So if I'm graphing cosine, cosine starts at the amp, ends at the amp, halfway is my lowest, in between 3 cross. So my cosine graph looks kind of like this. It's a lot of dotted lines down there, I'm sorry guys. Right, so that's what a cosine graph looks like. And remember, all we have to do to make it secant is add 2 things. Add asymptotes at the x-intercepts. You might say there's no x-intercepts. Well, I mean add asymptotes where it crosses your middle, your principal axis. So these are going to be your asymptotes where it crosses your principal axis. And then you add parabolas at the min-max points. And those parabolas are the graphs that we're looking for. That's the secant graph. And that's the idea, right? Just like everything else, move it down. Got your find your new middle with the vertical shift. Right, figure out your amps, add it to top and bottom, and like normal. Okay, last couple things, we're gonna put it all together to make it one big graph. Like always, right? Now we can put everything together. So the number in front of your sign is your amplitude. The number in front of your variable is your b. Phase shift's the thing on the inside, right? Inside x opposite. Don't forget if your phase shift, you gotta add the period to figure out your end. And vertical shifts on the outside. Outside, y, follow. Just like we always do. So let's do a couple of these. First one, y equals 3 sine 2/3. Theta minus 5 plus 4. Ooh, a lot going on there, right? So my amp is 3. Done. Period's 2 pi over b. That's going to suck because your b is 2/3. So not too bad, right? We know how to do this. 2 pi divided by 2/3. Which means multiply by the reciprocal. 2 pi times 3 over 2. These cancel, and I get 3 pi. Now, my phase shift, inside opposite, we're going to go plus pi. And my vertical shift, outside follow, plus 4. So let's graph this. So I got to go plus 4, so 1, 2, 3, 4. My amp is 3, so I gotta make sure I go 3 up also. 1, 2, 3, and 3 down. Okay, we're good there. My phase shift is pi, so my trick always to that is just count by that. So let's go plus pi, and add another pi, so 2 pi. Add another pi, so 3 pi. Add another one, so 4 pi. Right, I just always go with the phase shift is. Whatever the phase shift is, that's where I start and I keep on going. I could go further and more back, and that's where I'm stopping. Now let's do the things we always do. Right, so my middle is 4, I have it there. My amp is 3, so I could go 3 up. 1, 2, 3. So right here's the max I could go. Right, you go plus 3 up. I could go down 3 also. The lowest I could go is right here. Now I'm starting my phase shift at pi, so pi is right at the start, so my graph's gonna start right here. Now remember the way we figure out where we end? We're starting at pi. We just add the period. So in this case, our period is 3 pi. So I'm going to end at 4 pi. Hey, right here. I honestly didn't even plan that. I'm just so good sometimes. So you get that. And that's our little box our graph going to be in. So now we just graph sine, right? Sine starts at the amp. Sine starts at the middle. Ends at the middle. Halfway. Now the halfway between 1 and 4 is actually not so nice. Right, 1 plus 4 divided by 2 is 5 divided by 2. So 2.5, so it's like right here. Okay, most of the time you just eyeball it. Half between these two, I'm going to eyeball it. It's like right here. Half between these two is like right there. And we're going to graph our sine graph. Something to that effect. Probably my best one. It's not that great. But that's the idea, right? We're going to move that graph. Right pi, up 4, and we can graph like that. Again, this graph goes on forever. on both directions. It keeps on going and going and going. Let's do another one. Let's try to see what I got here. Let's do this one. Then we'll figure out what to do next. So, amp, period, phase shift, Virgo shift, right? Amp 2, period's 2 pi over b. That's my b, not my period. So 2 pi over 1/2. We're not scared anymore. 2 pi times the reciprocal. So 2 over 1. So 4 pi. My phase shift is going to be negative pi over 2. We do the opposite. And my vertical shift is going to be negative 2. So 1, 2, 3, 4. 1, 2, 3, 4. Remember the trick is whatever the phase shift, you do that. So like negative pi over 2. Then I'm going to add pi over 2. Because negative pi over 2 plus pi is 0. Then pi over 2. Then let's go 2 pi over 2. 3 pi over 2. And I've got news for you. It's going to go on for a while. 4 pi over 2. 5 pi over 2. 6 pi over 2. Luckily, I think the max is going to be 7 pi over 2. I think that's where we're ending. So 4 pi is a pretty big period. So that's kind of set up. It's still going. Right, then we do all the stuff we know how to do. We go, okay, where's my middle at? Middle's at negative 2. So right here. And my amp is 2. So from there, I'm going to go 2 up. And 2 down. Right, it's a high and a low I could go. I'm starting at negative pi over 2. So that's my furthest left. So negative pi over 2. And then we got to add, remember we're starting there. We got to add the period. Which in this case is 4 pi. So little math needed, common denominator. I get 8 pi plus negative pi is 7 pi over 2. So that's right here is where I'm ending. All the way at the end of my graph. So that's the basic. We got all that. Now we just got to graph it. So right here is the middle. We're doing a cosine graph, so scratch that. We're starting right here at the amplitude. And at the amplitude, halfway, again, most times this eyeball looks like it's 3, but if you're not sure, you can always check. Just add them up, divide by 2. Add your endpoint, and divide by 2. So I get 6 divided by 2, which is 3. So 3 pi over 2. So halfway is my lowest. And between these two right across, it's like right there and like right there. And that is my cosine graph. Moved over negative pi over 2 and moved down to the period of 4 pi. Let's skip down. We got the gist. Let's look at this one. I love these. So this one says write the equation. If we're going to move it 5 units to the left and 2 units down. So this is my phase shift. It's my vertical shift. So remember, this goes on the inside and you do the opposite. So left is negative, so do the opposite, take my own advice. So now it's going to the left. And then we're going to go down, so outside follow. And that's the equation, right? To the left, inside opposite, to make it a positive, you can move left, outside follow. They want to find the max of each graph. So if I want to find the max, here's a trick. It's if you notice over here, the max of my graph was this. What was it? It was the middle plus the amp. If I want the min, that's how I got to this max right here. Where the middle is, you add the amp. If you want the min, middle minus the amp. So that's all it is. It's just the vertical shift plus amp. If you want the min, it's a vertical shift minus the amp. Remember, vertical shift that's just the middle. That's why. So you just get your middle. And then you add the amp to it or subtract it. So in this case, my middle is 0 and my amp is 4. So that's my max. If I was doing this one, my middle is 5. So my graph's starting at like positive 5, and then I'm gonna add 4 to it. So my middle's gonna be 9. With that in mind, let's go to our last couple problems. So what these are our modeling problems. They're giving us some data and we have to make an equation out of it. So it's actually not as hard as it looks. The key thing here is to graph it. Kind of like graph it. So that's what I'm talking about. Water pool. The height of a water in a wave pool oscillates between a max of 14 feet and a minimum of 16 feet. So let's graph that real quick. So my max is 14 and my min is 6. So I'm going to go like my waves and kind of go like this in between those two. The wave generates 5 waves per minute. With the cosine function that represents the height of a water at a time t seconds. So 5 waves per minute is your period. So now it has to do with the period. It's not actually the period, but we'll get back to that right now. So it is a cosine graph. They tell us that. So okay, so we have like y equals, let's do a basic cosine b x minus c plus d. Remember, that's a very basic graph right there, right? Cosine. And we're going to find everything. Cosine has the height of the water at t seconds, blah, 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 blah. So if this is our graph, remember, first thing I do is find the middle. And the way you find the middle is just the halfway between these two. So you have 14 plus 6 equals 20 divided by 2, right? That's how you find the middle of anything. Add them up and divide by 2, and that is 10. So the middle of my graph is 10. You know what that 10 represents? The middle, vertical shift. If my middle is 10, look at my amp. It's 4. So we got that part taken care of. Now we don't have a horizontal shift, and we're not going to have any of these in this class. So we don't worry about that. It doesn't mention about moving left or right. All we got to do is find our B. That's where this comes in. We have 5 beats per minute. That means it does 5 periods in 1 minute. So we got to get our minute. There's 6. We're talking about seconds here, so there's 60 seconds in a minute. Divide that by 5, and you get 12 for the period, right? So it does 5 rotations in a minute. So 60 minutes divided by 5 it takes 12 seconds to do rotation. You're like, okay, that's my 12. No, it's not. Remember, it's a little tougher than that. Period's 2 pi over b. So let's put the 12 in for the period. 12 equals 2 pi over b. Let's solve, cross multiply. Divide by 12. B equals pi over 6. And that is my equation. I know that's all I'll take in right now. We'll go over it again and we're going to do another one. Right, but the general idea is like, okay, my maximum in is 14 and 6. So I like to draw it, 14, 6. Why do I draw it? Because it helps me find the middle. And all you have to do is add them up and divide by 2. Right, that's how you find the middle of anything. So add them up, divide by 2, I got 10. That is my vertical shift, because remember, that's your middle. This right here is always your middle. So once you have your middle, it's like, okay, well, what's the amp? We'll subtract these two, because that tells you amp's how high up it goes from the middle. So that's 4. We're never going to deal with the horizontal phase shift, because they don't talk about it, and we're never going to deal with it in this class. So all we have to do is find the period, and that's the toughest one. So they said they have 5 waves per minute. We're talking about seconds here. So 5 waves per minute means I got to figure out how long is one wave. So there's 60 seconds in a minute. 60 by 5 is 12. So it takes 12 seconds to do one wave. Then you're still not done, because I don't just plug in my period here. There's a little formula to that. So you got to plug in for the period and then solve the formula. And that's how you do it. Let's do one more and then we're done. While doing some moderate physical activity at a person's blood pressure oscillates between maximum 130 and a minimum of 90. So we're figuring out someone's blood pressure. Here's 90 as the min, and then 130 is the max. So again, the whole point is we're going to find the middle. The person's heart rate is 90 beats per minute. So it could do it 90 times in a minute. So 90 beats per minute. So again, we probably have to do the same thing as before. Write a sine function that represents blood pressure in time per second. So we're going to do a sine function this time. Now again, I don't even need to put the plus c because we're not ever going to do that. We're not going to phase shift it. So I just got to find all this stuff. Now this is the hardest one because that's how you get your b. Now it's not directly b, but that's how you get it. So we'll say that for last. First, let's find our middle. That's the easiest one. So you have 130 and 90. We have to find halfway between those two. So you just add them up and divide by 2. So I get 220 divided by 2, which is 110. So that's my phase shift, my vertical shift. That's the middle. Now once I have that, well, I can find the amp. Just subtract 130 from 110, or 110 from 130, and you get 20. That's how high up and how low I go. So the only thing left is to find my B. So it's 90 beats per minute. So just like before, we have 60. We have 60. We got to do this in seconds. So we have 60 seconds in a minute. So it's 90 beats per minute. So we're going to divide 60 by 90, and we're going to get, if you reduce it, you get 6 over 9, which is 2/3. So it does 2/3. It takes 2/3 of a second to do a beat. That's all good and great, but that's not my B. The period is 2 pi over 3. 2 pi over b, sorry. And that's my period, right? That's how long it takes me to for your heart to beat. So that's my period. 2 over 3 equals 2 pi over b. I would cross multiply. 2b equals 2 pi equals 6 pi, sorry. Divide by 2. B equals 3 pi. So that is my b, and that is the problem. Y equals 20 sine 3 pi x plus 110. I put the 3 pi x outside also. And that's it. We're done with this lesson.